Hello everyone, I am Anjan and welcome to the 29th video tutorial of the Verilog course series. In this video, you will be getting to know how the decoration lights can work in a real life FPGA and to how to design a Verilog code for it. Actually, this is a continuation for LED blink in FPGA videos, which you can watch them in the Star Scratch YouTube channel playlist, which I had earlier covered it. And if you won't watch it, I recommend you to watch it so that you can understand in a better way in this decoration lights video. And there will be a part 2 of this video which will be covering mostly the simulation part of this video, and that is the post coding part. And let's move to the pre-coding part. This is the pre-coding part where you will be seeing the FPGA board and how my design is going to be. In my design, I will be using 16 LEDs in this basis board. There is 16 LEDs, you can watch them as LD0, LD1 and up to LD15. And what is my design is this LED will glow for 1 second and will stop, and this after that success following, this LED will glow and will stop for after 1 second. Following, this LED will glow for 1 second and will stop, and following this will grow, and there will be a sequence of LEDs will be going up to LD15, and after LED will stop glowing, it will repeat from the LD0, and this sequence will be flowing, and you will be finding it like a decoration. Let's move to another slide. This slide I already covered in the LED blink in FPGA videos. From this slide you have to remember that I will be using 4 bits for the counting purpose in the parent and the child clock pulses. You can understand these words because if you watch my previous videos on the LED blink in FPGA. And I will be using 10 counts. Let's move on to the other slide. This is a state machine diagram for a single LED blink. In my Verilog code, I will be using this one for blinking 16 LED blinks, and I will also using an always block for extra to get access to any single LEDs. You will be getting more clarity while I will be explaining the coding part. Let's move to the coding part. Here is my code for decoration lights, and here is the module. I declared decoration underscore LGT, and here I given the inputs, that is RST, reset and clock, and I given the output, that is 16-bit output Y. And here is, and if you observe my previous video of LED blink, I have taken the similar inputs, but the output is a single bit, but here I took the 16-bit, 15-bit, 16-bit, right? This is similar to the part which I taken the LED blink, but here it is LED I took there as X, and I took it as a 16-bit because the output is 16, and I took the parameters as up and down instead of taking on and off. You can also take above, below, it's up to you. And here I declared the always block which I taken like similarly in the LED blink video, and for every passage of clock there will be a reset. If the reset is equal to 1, count edge, state edge and LED edge, you can also take it as X edge or anything, will be 0, or else the present state will be getting the future state value. Like count next will be given to count edge, state next will be given to state next, X next will be given to X edge. And here ended the always block. Coming to this always block, I taken always block. In this always block, this is the default value, and for the state edge case, if up, this will the condition, that is if the count next equal to 10, for 10 power 7 seconds, that is for every 10 seconds, for every 10 power 7 seconds I will be getting a clock change. That will be count equal to 10. I explained it in the, I told here. To remember, I will be taking 10 counts and bits equal to 4 bits. it I can count next equal to 10, and state, then the state will be changing, jumping to state down, and count next will be setting to reset it to 0, and next that will be the LED which I will be taken is going to be incremented. Like if the 10 seconds it is glown and off, I will be showing it here. After 10 seconds it is glown and off. After that the LED should be jumped to this one, so that I incremented the X-edge to this one by 1 bit, and else it will be in the same LED, and state will be in the same state, and count will be incrementing, like for 1 bit 0 0 0 1 1 0 1 1, like that it will be incrementing up to 10. Else if it is in the down condition, if the count reaches to 10, the state will be jumped to up, and the count will be resetted to 0, and the X next will be, that the LED will be incremented by 1. Else it will be remains in the same condition, and the LED will be remains in the same condition, and the count next will be incrementing by 1 up to 10, so that if it reaches 10, so that it will be changing to the other states. And this is the main always block. Instead of in the LED blink, I used it data flow modeling to give the output, whereas in this one I will be using an always block, procedural block for giving that value. Here if you observe, in the starting of the code I took integer I, because here the output is Y. Okay, to get to the output Y, I took another LED called final LED which stores the values, that is LED equal to X-reg, the present value I given to the X. If reset this Y equal to 0, that is all the LEDs will be shut on, or else I will be incrementing up to 15, that is 16 LEDs. If X equal to Y, which means the X value, which you can say here, this X value, that is the LED value, is equal to I means the incremented value. I is taken initially as 0. If LED is 0, first LED, that is 0 LED, and 0 increment value. If both are equal, then the 0, Y of 0, that is the first LED, will be blink. This is the condition. This is just similar to the one of my videos that is related to I think so 2 to 4 decoder or something. There also there will be the truth table, like truth table, there is also similar condition. I used the similar code there also. And here in the else part, else there will be 0, all the other bulbs will be in the 0 condition. And here I ended the for loop, and I given if X equal to 16, then X-edge will be equal to 0, because after the 16 value it should be given taken as 0, so that it will be again repeating this loop. And here I ended the module. And here now I will be ending this video, and I will be continuing the post coding part in the second part of this video. And if you are willing to explore more on Verilog questions, do check out the description box below for more questions related to Verilog. And if you like the video, do hit the like button below and share to your friends, and subscribe to the StarScratch YouTube channel. Thank you.